Welcome back to Discovering Geometry with Mrs. Berry. This is Lesson 52. We're talking more about area, and today we will be talking about the area of regular polygons. So look at a regular hexagon. Can you divide it into triangles? How is the best way to divide it into triangles? Let's start from the center. Here we have 6 isosceles triangles. We can divide any regular polygon into congruent isosceles triangles by drawing segments from the vertices to the center. The center of the polygon is actually the center of the circumscribed circle. How will this help us in finding area? Let's use an investigation. Consider a regular pentagon with side length S divided into congruent isosceles triangles. Each triangle has a base of S and a height of A. What is the area of one isosceles triangle in terms of A and S? So looking at this triangle right here, we know that the area of this triangle is 1/2 base times height. The base is going to be S and the height is going to be A. So the area of one triangle is 1/2 A times S. What is the area of the entire pentagon? Well, that's one triangle, and this pentagon has 5 triangles that are all the same. So it would be 5 times 1/2 times A times S. Now we're going to repeat these steps with the other regular polygons to complete the table. So again, here in the first one we have 5 times 1/2 times A times S. Let's look at a hexagon. We know that there are going to be 6 triangles in this hexagon. If A is right here and S is up here, what is the area of the entire hexagon? Well, it's 1/2 A times S, and then there are 6 triangles in a hexagon. What about a heptagon? One triangle is going to be A times S, or 1/2 A times S, and there are 7 triangles in a heptagon. How about an octagon? Hopefully you're starting to see the pattern. One triangle is 1/2 A times S, and there will be 8 triangles in an octagon. A nonagon, 9 triangles with each triangle being 1/2 A times S. How about a decagon? Same thing. So what happens when we have n number of sides? Be n times 1/2 A times S. So the A has a special meaning. The apothem is the line from the center of the regular polygon to a side intersecting the side at a right angle. So in this pentagon, this line that we draw right here is the apothem, and that ends up being the height of our triangle because it is intersecting the side at a right angle. It's called the apothem. So what is the formula for the area of a regular polygon? It was what we came up with, that last box with the n number of sides. So the area of a regular polygon is A equals 1/2 NAS. N is the number of sides, A is the apothem, or the height of that small triangle, S is the length of each side, or the base of our small triangle, and 1/2 because a triangle is 1/2 base times height. Now the length of each side times the number of sides is called the perimeter. So the perimeter is equal to the number of sides and the length of each side. So we could write the formula for the area where we substitute the N and the S for P, the perimeter, and say that the area is 1/2 apothem times perimeter. Using what we know, let's try this example. What is the area of a regular decagon when its perimeter is 65 and the apothem is 4.2? Now, a decagon is 10 sides, but we won't even need that because we're given its perimeter. And we just said the area was 1/2 apothem times perimeter. The apothem is 4.2 centimeters. The perimeter is 65 centimeters. So our area is 1/2 4.2 times 65. 1/2 times 4.2 is going to be 2.1. 2.1 times 65 will be 136.5. And this is centimeters squared because originally we had centimeters times centimeters. So these area formulas you can memorize, or you can just remember where they came from and work it out anytime you need that formula.